So now what we first have to think about is, what is the first cation? Okay? So guys, when it's asking for the first cation, which one is it talking about?
The one that precipitated first.
The one that precipitated first, which was this one. Okay? So the first cation is clearly going to be silver. So that's what we're asking for, is concentration of silver. What's the second cation?
Lead.
The lead. Now, you know something about the lead, and you know something about this when the second cation precipitates. It will precipitate when, besides lead, what else do you have?
Iodine.
Go ahead, Amina.
Is it first and second because that one's gonna precipitate first?
Yes. If it precipitated first, we're going to call this the first cation, and this precipitated second is the second cation. Right. Okay. So, what has to be true in order for lead, the second cation, to precipitate?
Silver has precipitate.
No.
Iodine.
Yes. Iodine has to be greater than this concentration, right? So that's what you need to focus on, okay? This will precipitate when iodide is equal to 2.7 times 10 to the negative 3 molar. So, what we're solving for is this, but what we have to use is this. So, which KSP expression am I going to have to use? The one with the lead or the one with the silver? The one with the silver, because we have to solve for silver. I can't solve for silver if silver's not in the equation, right? Okay, so we simply write down our KSP for silver and iodide. We know KSP, it's 8.3 times 10 to the negative 17. We don't know silver, that's what we're trying to solve for. The iodide is going to be this one, 2.7 times 10 to the negative 3 molar. Does that make sense?
Yeah.
Because this is what has to be true when the second one starts precipitating. So let's throw that in our calculators, see what you get. Probably get something pretty low. What'd y'all get?
Is it?
Yeah. You get silver equals 3.1 times 10 to the negative 14. Wow. So it started at 0.002 and went all the way down to 3.1 times 10 to the negative 14. That's huge. Okay? So this is the answer to how much is left. Sometimes you're asked, what percentage was removed? What is percent? Like the real easy definition.
Part of the whole.
Part of the whole. So this is the part that's left. If you're asked for percentage of silver, like this would be the percentage of silver that remains. This is the amount that remains, right? Over the total amount that it started with times 100. Let's see how much remains. I got that too, yes. I get 1.5 times 10 to the negative 9th percent remains. That's not very much, is it? So what percentage was removed? 99.9999, right? A huge percentage was
Almost
removed.
everything.
Yeah. And actually, this whole process is called selective precipitation, where you kind of have two ions and you're kind of getting one precipitated before the other one starts precipitating. And if you can remove like I don't know what the threshold is. I don't know if it's 95%, but certainly 99% is pretty good. If you can remove 99% of one before you start removing the other, this is an excellent separation method. Does that make sense? Yeah. Yes,
So
Alex.
the first one has to happen first before the second one, or do they happen instantaneously and then?
No, this one happens first. This one won't, I mean, this will precipitate as soon as you get to that concentration. And so in between 4.2 times 10 to the negative 14 and 2.7 times 10 to the negative 3, only the silver will be precipitated.
Yeah.
And every time it precipitates, it takes some of that added iodide away, and you got to put it back in. So it's only when the concentration gets up to this will it start precipitating that. Okay? Does that make sense? Number 10 on your review sheet actually has a problem that goes all the way to this level. Okay? All right.